Good morning, students. Today we discuss about Fourier integrals. So in first year you have gone through the topic Fourier series, how you can express a function f of x as a Fourier series. Fourier integrals are the generalization of Fourier series. That is, you can express a function as a Fourier integral in the form of an integral. Under suitable condition, you can write the function f of x as an integral, which is called Fourier integral. The conditions with which a function can be expressed as a Fourier integrals are called Dirichlet's condition. I think you also gone through that in first year. So Dirichlet's conditions are given by, there are three conditions. First is, if the function f of x is said to satisfy Dirichlet's condition, the first is given by f of x is periodic, single valued and finite. Second is, it has a finite number of discontinuities in any period. That is, it has a finite number of breaks in the graph you can see in a particular interval. Third is, it has at most a finite number of maxima and minima. That is, when you take a sine function, you can see that maximum point and minimum point, there will be a finite number of maximum and minimum point in a particular interval. So, these are the three conditions to be satisfied by a function to express it as a Fourier integral. We are not going deep into these conditions. You have to just by heart these 3 points. The Fourier integrals are given by the Fourier integral theorem. That is, if f of x is a function satisfying the Dirichlet condition, this Fourier integral representation is given by f of x is equal to integral 0 to infinity a omega cos omega x plus b of omega sin omega x d omega, where a of omega is given by 1 by pi integral minus infinity to infinity f of nu cos omega nu d nu. B of omega is equal to 1 by pi integral minus infinity to infinity f of nu sin omega nu d nu. This f of nu is obtained as f of x you have. You can replace x by nu, you will get f of nu. So this is the representation of a function as a Fourier integral. Now you can have Fourier cosine integral and Fourier sine integral also. The Fourier cosine integral is given by f of x is equal to integral 0 to infinity a of omega cos omega x d omega. Its b omega part will be 0, considering the function as an even function. And a of omega is given by 2 by pi integral 0 to infinity f of nu cos omega nu d nu. Here it is 2 by pi. Now similarly, Fourier sine integral, we have a omega part 0. We have f of x is equal to integral 0 to infinity b of omega sin omega x d omega, which will be a integral representation in sine function, where b of omega is 2 by pi integral 0 to infinity f of nu sin omega nu d nu. So you have 3 set of formulas, as Fourier integral, Fourier cosine integral and Fourier sine integral. So all of you by heart these 3 set of formulas, and we will do problems to represent a function as a Fourier integral, cosine integral or sine integral. Let me explain the first problem. Find the Fourier integral of f of x is equal to 1 for mod x less than 1, 0 for modulus x greater than 1. We have the Fourier integral of f of x given by integral 0 to infinity a of omega cos omega x plus b of omega sin omega x d omega. Here our aim is to find a of omega and b of omega and substitute in this expression so that you can express f of x as an integral form, which is called Fourier integral. Now a of omega is the formula 1 by pi integral minus infinity to infinity f of nu cos omega nu d nu. Now we will substitute the values here. As the integral is from minus infinity to infinity, the function f of x is given in modulus x less than 1. We already discussed this before, as modulus x less than 1 means minus 1 less than x less than 1. Modulus x greater than 1 means all the other points except minus 1 less than x less than 1. So substituting here, the integral becomes minus 1 to 1 f of nu. F of nu is equal to 1. Since f of x is equal to 1 here, f of nu is also equal to 1. So it becomes minus 1 to 1 cos omega nu d nu. Now integrate it 1 by pi cos omega nu, it's sin omega nu by omega minus 1 to 1 within the limit 1 by pi omega, and upper limit substituting nu equal to 1 you get sin omega, nu equal to minus 1 you get sin of minus omega. Sin of minus omega is minus of sin omega, which becomes sin omega plus sin omega. So you have 2 sin omega divided by pi omega is a omega. Now b omega is equal to 1 by pi into minus infinity to infinity f of nu sin omega nu d nu. Here f of nu is equal to 1 into minus 1 to 1 sin omega nu d nu. Integrating sin omega nu integral is minus cos omega nu divided by omega. Within the limit minus 1 to 1. Here nu is the variable. Okay. So substituting for nu you get minus 1 by pi omega cos omega minus cos of minus omega is cos omega itself. So cos omega minus cos omega, it becomes 0. So b omega is equal to 0. Now substituting a omega and b omega in this Fourier integral representation, we get f of x is equal to integral 0 to infinity 2 sin omega by pi omega cos omega x plus 0 into sin omega x d omega. The second term vanishes and what remains is 2 by pi into 0 to infinity sin omega by omega cos omega x d omega is the Fourier integral representation of the function f of x. And I already told you that you need not have to do this integration, because what we are doing here is we are representing the function in an integral form. So this is how we solve a function or express a function as a Fourier integral. Now another problem, find the Fourier cosine integral of f of x where it's e raised to minus x 0 less than x less than a and 0 for x greater than a. So our formula for Fourier cosine integral is f of x is integral 0 to infinity a omega cos omega x d omega, where a omega is equal to 2 by pi integral 0 to infinity f of nu cos omega nu d nu. So we will substitute for f of nu. Here f of x is e raised to minus x. So f of nu is e raised to minus nu. Replace x by the term nu. Now we have to split the interval. 0 to infinity is 0 to a and a to infinity. So 0 to a here exists. So in 0 to a e raised to minus nu cos omega nu d nu. Now evaluating the integral, we have a formula for this integral 0 to infinity e raised to ax cos bx dx. We use that formula here so that we will get 2 by pi e raised to a divided by a square plus b square form. So e raised to minus nu by a is equal to 1. So 1 square plus omega square into a cos omega x plus b sin omega is that form. Here we will apply the formula here. So you will get minus 1 cos omega nu plus omega sin omega nu. All of you do remember the formula for integral e raised to ax cos bx dx. So substituting the limit 0 to a, you get 2 by pi into 1 plus omega square is constant. Applying limit on the term nu, you get e raised to minus a upper limit minus 1 into cos omega a plus omega into sin omega a minus lower limit is 0. So you get e raised to 0 into minus 1 into cos 0 is 1. So minus 1 into 1 plus omega into sin 0 is 0. So the second term becomes 0. So now just write it down. 2 by pi into 1 plus omega square. We have minus e raised to minus a cos omega a plus e raised to minus a sin omega a plus minus minus plus e raised to 0 is 1. So you will write f of x is 2 by pi into 0 to infinity 2 by pi 1 plus omega square into 1 minus e raised to minus a cos omega a plus e raised to minus a omega sin omega a into cos omega x d omega is the Fourier cosine integral representation of the given function. Another problem, find the Fourier sine integral of f of x is equal to x for 0 less than x less than a and 0 for x greater than a. Formula for Fourier sine integral is f of x is integral 0 to infinity b of omega sin omega x d omega, where b of omega is 2 by pi integral 0 to infinity f of nu sin omega nu d nu. Here f of nu is nu. F of x is x, so f of nu is nu within the limit 0 to a. So splitting the interval 2 by pi integral 0 to a, f of nu is nu sin omega nu d nu. Now we will apply here uv rule. First function is nu. So 2 by pi into first function into nu into integral of sin omega nu is minus cos omega nu by omega within the limit 0 to a minus derivative of nu is 1 into minus 1 by omega into cos omega nu is entirely sin omega nu by omega within the limit 0 to a. Applying the limit 2 by pi minus 1 by omega, putting nu is equal to a, you get a cos omega a minus putting nu is equal to 0, lower limit is 0 plus 1 by omega square sin omega a minus lower limit is sin 0. So the result is 2 by pi minus a cos omega a by omega plus sin omega a by omega square. So the Fourier sine integral is obtained by substituting here f of x is equal to 2 by pi into 0 to infinity minus a cos omega a by omega plus sin omega a by omega square into sin omega x d omega. So the problems are just to apply the values to the formula. So you by heart all the three formulas of Fourier integral representation, and when you have a function given, you just identify its value and put it in the integral, find out b omega and a omega using the given formulas, substitute it in the Fourier integral representation. So all of you go through the problems and write it down, and we will do more problems when we come to the class. Okay, thank you.